The next part is going to ask us to graph given a slope and a y-intercept. And these problems are a little different because here I'm writing the equation in the slope-intercept form. So let's take a look at this. These are a little bit more difficult than the ones you'll see, because again, they'll just say the slope is, and then they'll say maybe 2. And that's the case here. The slope is 2. And we need to know that the slope is the number out in front of x. And then they'll say the y-intercept. The y-intercept's, let's say, -1. Well, that's this number right here. That's our y-intercept. So I want you to be familiar with where the slope is and where the y-intercept is. But it only works, again, when we are in slope-intercept form. Remember, slope-intercept form is when y is by itself. It's y equals mx plus b. So we start with the y-intercept, down one space, put that dot right there, and then use the slope. The slope is 2 to 1. So that means I'm going to go up 2 spaces. Again, that slope is 2 over 1. So up 2 over 1. Up 2 over 1, up 2 over 1. I could also go the other way. It's also the same thing as -2 over -1. So I could go down 2, left 1, down 2, left 1. And that gets me on to that line. And then I can just draw the line between those points. So again, the slope is important because it's the constant change of the line, but the y-intercept is also important because we need to know where to start the graph. And that's what we're doing here. See, the y-intercept is the number where x is 0. So if you cancel out this -1/2 x, you're left with this number right here. That is our y-intercept. And then the number out in front of the x term, well, that is our slope. That's what changes the values of x to make the outputs later on. In this case, it is our slope. And so the slope, again, remember that slope is the rise over the run. It equals that -1 over 2. So that tells me what to do in the y direction and the x direction. But again, we got to start somewhere. We got to start with the y-intercept. So we go up 3 spaces, put our dot, and then we use the slope. The slope, again, is that number, -1 to 2. So this tells me to go down 1 space and then 2 to the right. So that's what I'll do here. Down 1, 2 to the right. Down 1, 2 to the right. Down 1, 2 to the right. Or could go the other way. It could represent this same thing as 2 over -1. See, it's still just one negative, but then I go the other direction. I go up and then left. So up 1, or up, oops, I rewrote that wrong. Did you catch my error in there? I made a big time error. I took the reciprocal of it. I didn't want to do that. I wanted to just take the number and switch the signs. So hopefully you caught that before I did. So we have 1 over -2. So I'm going up 1 space and then 2 to the left. Up 1, 2 to the left. And then from there, we can draw that line. So that line just goes downhill from left to right. And that's the big difference here, is negative slopes are always going to head downhill from left to right. Positives go the opposite. Well, the next problem, it's a good one for xy intercepts, but I'm going to work on the slope-intercept form here. First thing I'm going to do with this problem is I'm going to get y by itself. If I want to use slope-intercept form, I'm going to move this 2x over to the other side, subtract it from both sides. So when I do that, what I'm left with is this 3y, and it equals now -2x plus 9. And so now I've got one more step. I'm going to move this. So we move that -2x back to the other side, and what we're left with is this 3y equals -2x plus 9. So what I'm going to do from this point is divide by 3. Now remember, you got to divide every number by 3, not only the 9 but the 2x as well. So what I've got is this y, and it equals -2/3 x and then a plus 3. So you see I divided, and 3 doesn't go into 2 evenly, so you leave it as a fraction. So what we're going to do is start by plotting that y-intercept, positive 3, so we go up 3 spaces, put a dot there, and then use the slope. Remember that slope is negative 2 to 3, so down 2 over 3 to the right, down 2, 3 to the right. Or I could go the other way. I could go up. Let's see, actually, I didn't quite make it over there at that point right there. So let me erase that. You got to go all the way over those full spaces there. So down 2, 3, 1, 2, 3 to the right. Or I could go the other way, which is up 2, 3 to the left. 1, 2, 3. Up 2, 3 to the left. And then you'll notice that you're in line. Now, if you made a mistake like I did, and you tried drawing the line, it wouldn't quite be straight as possible, because the points weren't lined up. They should always have consistent slope when you're drawing lines. Lines always have that consistent slope. So let's take a look at the next one. Next one, I've got the same situation. Oh, a little bit different. I guess y's on the other side. I don't have to move anything. What's different is y is on the other side, so we have to be careful what the y-intercept is. And here, that y-intercept is negative 2. So we're just going to go down 2 spaces, put a dot there, and then use the slope. Ooh, what's the slope here? I see no number out in front of x, but there's always a number you can put there. It's 1. 1 times a number doesn't change it. So our slope equals 1. Well, that could be written as a fraction as 1 over 1. So that means I'm just going to go up and to the right. Up 1 to the right 1. Up 1 to the right 1. And you could do that a few times. You could also go the other way. Down to the left. Down to the left. Down to the left. And you're still on that line. Well, we go ahead and draw a line between those points. And we've got our answer. There it is, the graph. Well, those are some of the problems that you'll see tonight. And then after that, we'll be reviewing more for our Benchmark 1 test.